Namaskar, Adab, Sat Sri Akal. How are you, students? I hope that all of you are doing very good. So let's start the third lecture of our magnetism portion. What we have discussed, if I will telling you about, we have discussed about the magnetic field calculation, Ampere circuit's law, and these kind of the things. Okay. And in this lecture, we are going to discuss first time about magnetic force. Yes, we are going to discuss about magnetic force. Let's suppose what will be happening if I am keeping a charge in a magnetic field separately, an electric field separately, and an electromagnetic field also. What is electromagnetic field, students? Electromagnetic field, from its name itself, it is very clear that there will be present some electric field as well as some magnetic field as well. So both kind of things, if they are present, that means that kind of field will be called as electromagnetic field. Clear? So let's begin and let's understand the behavior. Are you ready to learn something new? Are you ready? So begin with your pen and paper. Be ready. Let's start without wasting any further time. Fine. The first thing is I have given you. I have told you that I will tell you firstly about the little bit from the upper side. First thing you have to remember, this is the very first and itself very important, that a magnetic field cannot change the speed of the charged particle. Magnetic field cannot change the speed of the charged particle. Why? There is a reason also, I will tell you. Because after having the formula, always the magnetic field that is applied is always perpendicular to the velocity, and if anything is perpendicular to the velocity, let's suppose this is a velocity, this is a magnetic force that is acting, I can say this magnetic force doesn't have any application or any component on the side of velocity. So that's why we always say that this magnetic force can never change the velocity. It always helps you change the direction. If you remember a little bit about projectile motion, if any students know about projectile motion, how projectile motion is happening or how circular motion is happening. Let's suppose you have projected something. I can say at every moment on this motion, there is a force that is acting in downward direction. That means this perpendicular force is always helping in changing the direction. But here it changes the velocity also. But let's suppose any particle is performing a circular motion. Okay, any particle is performing a circular motion. For performing circular motion, what I can say? Always there is a mandatory centripetal force. Always there is a mandatory centripetal force. And I can say this centripetal force is perpendicular to the velocity at every single point. Correct? That means what we say there, that centripetal force never changes the velocity. Centripetal force only decides the direction. Centripetal force helps you to changing the velocity vector at every single point. Correct? Same is the kind of behavior of magnetic force as well. So first thing is very clear that it will never change the speed of the particle. That means acceleration due to magnetic force only changes the direction of the motion. The acceleration that will be coming from magnetic force will only be the centripetal force. It is not the tangential force. Always tangential force helps you to change the velocity. I hope that this much will be clear to you firstly. Let's suppose we have to check what will be the speed of the particle, and what you have applied here. You have applied a simple, from higher potential to lower potential, a simple electric field. Simple electric field you have applied, and a charged body is at rest. Okay, and you want to calculate what will be the velocity when you release this thing. Okay, initially the velocity is 0. How will be writing? V is equals to u plus at. Initially, if it is 0, that means u will be equals to 0. The velocity that you will be writing is equals to acceleration into time t. How will be writing acceleration? Tell me, what is the force that will be applied on this? Force has the same direction, and force can be written as q into e. Force can be written as q into e, and if I am writing this further as force can be written as mass into acceleration is equal to q into e, and acceleration can be written as q into e divided by m. So now just put the same acceleration here, q into e divided by m, and that can be said as what? Velocity. That can be written as what? Velocity, q e divided by m into time. Is it clear? This can, you can simply write it as the velocity, how the velocity will be dependent on the electric field. Correct? Here there is no magnetic field introduced. Okay. So what is the force on the charge in electric field? I have already told you that it is equals to q into e. So due to this force, what will be happening? Due to this electrostatic force, it will acquire some acceleration, it will start moving. But what I told you, if there is a magnetic force, it will not change the velocity. Again and again I am repeating, this is a very important line. Okay. Now here I have introduced a magnetic field. Now let's understand the behavior. A stationary charged particle is placed on a magnetic field. The direction of the magnetic field into the plane appears, but no motion of the particle is observed under this circumstance. If there is a charge you have dropped. Okay, you have kept a charge in a constant magnetic field. Magnetic field, I hope that this is clear, visible to you, that it is going inside the plate. When we have observed, there was no motion into this complete system, nothing was moving anywhere. But second case, when a moving charge particle is placed again in the magnetic field, the charge particle follow a curved path as shown in the figure. Okay, at each point of the path, the speed or it is now given some velocity v. Now it is given some velocity v. Now then what will be happening? When it was observed, I will tell you the next portion is only about that force. For finding the direction of force, I am telling here only, it will be simply v cross b. Anyways, here if you are not understanding that also, there is no problem, I will tell you. So I told you that notice this motion. What you are noticing here, that it is only changing its direction. It is only changing its direction. But when you are noticing the magnitude, it is here also v, it is here also v, and I can say it is here also v. So what you have noticed from this magnetic force is not changing the velocity, it is only changing the direction. I hope that this will be very clear to you. So let's now proceed. Now come to the magnitude. Okay sir, fine, it is not changing the velocity, but how much force is acting? Let's discuss that also. So experimentally this data is calculated. Force that we have calculated was becoming directly proportional to the velocity. Force that we have calculated was directly proportional to the velocity that was perpendicular, and force directly was proportional to the magnetic field as well. And when we have combined this, we have got that force is directly proportional to q v perpendicular into b. And when we have written this properly and constant k becomes equals to 1, we have got the formula v perpendicular into b, or this is also written as force is equal to qvb sine of theta. It is also written as vb sine of theta, that means it is a cross product q into v cross b. This is the formula that you have to always remember. From here itself it is very clear that force, how you will be finding the magnetic force, v cross b. That means force will always be perpendicular to velocity and the magnetic field. That's why I have told you in the first part also now, because force and velocity are always perpendicular. That means there is no component of force who is contributing in the velocity side. That means there is no acceleration of this force vector which is going to increase or decrease the velocity component. Correct? So this is what you have to write. And for direction purpose, this is the direction. How will be finding direction? Direction will be calculated by v cross b. Always remember, v cross b always is going to give you the direction. Correct? We will be having about direction, don't worry, we will be having a lot of things, but whatever I have taught you, this should be very clear to you. So when will be the maximum force will be applied? When will be the maximum force will be applied? Tell me. When will the maximum force will be applied? What is the formula? QVB sine of theta. That means theta, when theta becomes sine of theta becomes maximum at 90 degree. What is sine of 91? That means at that value, what I can say, it will be achieving its maximum. Correct? Now see. Find the direction of the following cases. Here to find, two cases are given here, and the directions are also shown here. This is x-axis, this is z-axis, and this is y-axis. X-axis, y-axis, and z-axis you can assume coming outside the plane, that is z-axis. You have to tell me where this charge is going to move. How will you find it? Firstly, find a direction. The direction is decided by the magnetic force. Tell me what is the direction you will be saying? V cross B. This is the velocity. This is taking your hand in the direction of V. Show your palm to B. Show your palm to B. Show your palm to B. And B. V cross B. What is the direction that is coming? Can you say the direction that is coming is outside the plane? Direction that is coming is outside the plane. That is what I can say. What is the direction of magnetic force? Direction of magnetic force is outside the plane. Which option is giving you along k cap? K cap, k cap, k cap. Options are not written here properly, but here I can see this is k, this is k. Okay, let's see about the second option also. Now here what you will see, this is velocity. Velocity is inside the board. Here it is represented, actually not inside the board, it is actually outside the board. Outside the dot is representing outside the board. Take your hand towards outside the board. Now what will do? V cross B. Show your palm to B. Show your palm to B. V cross B. And curl your fingers. V cross B. What is the direction that you are getting for the force? For the force you are getting this direction, force F. That means for the second time, the direction that you will be coming is positive of J cap. plus of j, either this, either this. I guess that if there is no misprint here, that means option C will be definitely correct. Option C will be definitely correct. Okay, wait. I forgot that there is a negative sign. Option A is correct along K, that is fine. Here what you are doing, V. Take your hand in the direction of V. V cross Z. What is the direction you are getting? Upside. Correct now? This is the direction that you are getting. But beta, you have to remember that also that there is not a positive charge, there is a negative sign. If there is a negative sign when you are writing this force, you will be writing minus of QB. Minus of QBV ultimately is going to reverse this direction. That means the net direction is not this, net direction is towards downward direction, that is minus of this. That's why option A is correct. Is it clear? I thought that there is a positive charge, but it is very important, good point that we have noticed there. When there is a negative charge, the final direction of force will be reversed. And we have did same thing in the electrostatics as well. When we have write the force direction, it was same as the electric field direction. But when there was a negative charge, we have reversed this direction. We have did a lot of times the same thing. Okay. So you have to be very careful about the sign conventions. Right. Option A will be correct. Now comes to Lorentz force. What is Lorentz? Lorentz was a scientist. Okay, Hendrik Lorentz was a scientist who have given this electromagnetic force. It is a combined effect of electrostatic force as well as magnetic force, correct? And this combined force is simply called as Lorentz force. Very simple thing, nothing special. This Lorentz force FL can be said as magnetic force plus of electrostatic force. And all these things are in vector portion, and magnetic force can be written as QVB, or if QV cross B also you can write, and here it will be Q into E. Correct? This is what here you can see, if I have to generate an electromagnetic field, how I will be generating. Here you can see there is a magnetic force, magnetic field is here, and the direction inside the plane there is a this is the electric field that you are having, and here it is a magnetic field that you are having inside the plane. So this kind of plane arc is called as electromagnetic plane. Now we'll be watching different behaviors when charge will be left at rest, what will be happening. If charge is in motion, then what will be happening. All these things we are going to understand by keeping charges in different conditions, and let's understand what kind of trajectory they are going to follow. All these things are very important. Okay. So let's see this portion, interesting portion. I told you already, it is a combination of electrostatic force as well as magnetic force, that means QE plus QV cross B. This will be the Lorentz force. First one, case 1, when charge is at rest. When charge is left at rest in an electromagnetic field, charge is at rest. Charge is at rest, then what will be happening? Tell me what will be the force that will be applied here. What is electrostatic force? Electrostatic force is equals to Q into E, and what is magnetic force? It is equals to QVP. But what I can say about the velocity? Initially what will be the velocity? 0. That means initially what is the magnetic force? That is the magnetic force is going to be 0. That means which force will be only acting? Only the electrostatic force for the initial portion. That means there will be an electrostatic force that will be acting here, and it will bring some velocity also in the x direction, because the direction for electric field is x. And how you will be writing that velocity? I have already told you Vx will be written as ux plus ax into t. Ux will be 0 because initially velocity is 0. Vx is equals to acceleration in x direction is equal to q into e divided by m into t. As simple as that, no rocket science. Correct? Clear? Now case 2, when charge is moving parallel to both electric field and magnetic field. When charge is moving parallel to both electric field and magnetic field. Now this time we will be having, how will be writing electrostatic force? Electrostatic force will be simply Q into B. And what you can write for magnetic force? Magnetic force can be written as Q into V cross B. V cross B, that means understand what? VB sine of theta. This angle theta is between whom? This angle theta is between the velocity vector and the magnetic field vector. What is the angle between the velocity vector and the magnetic field vector? Theta is equals to 0 degree. Tell me students, what is sine of 0? What is sine of 0? Can I say it is 0? That means what I can say about the magnetic force? Magnetic force is also going to be again 0, always. Correct? Whenever it is parallel moving to the magnetic field, the force will be 0. Now this time how I will be writing the velocity? Simply again electrostatic force will be acting as simple as that. Vx will be equals to ux plus ax into t. This time ux is not 0 because initially already there is some velocity, and how much that velocity is nothing but v naught plus ax. What is the acceleration in x direction? You'll be writing qe divided by m into t. That is the velocity, final velocity you will be telling in the x direction. No need to remember these things. All these things are quite logical that you can understand at the time only. Different cases will be given. Just understand the concept, what is happening in different cases. You can write it by yourself, no problem in that. Next thing given is charge is moving in perpendicular to the both electric field and magnetic field. It is moving perpendicular to both electric field and magnetic field. In these kind of cases, what will be happening? Here electric field and magnetic field are parallel to each other. Now you have to write what will be the what kind of motion it is going to follow. See, firstly write what is the force that is present in x direction. Can you say it will be force that will be applied in x direction is this electrostatic force q into a. And what is the direction for magnetic force? Should we calculate? How will we calculate it? V cross B. Initially all the velocity is in y direction. Initially the velocity in x direction is equal to 0. That means do V. Take your hand in the direction of V. Show your palm to B. And just do V cross B. When you curl the finger, what is the direction that you are getting? You are getting for inside the plane as magnetic force. Magnetic force will be coming where? Inside the direction. That means if you have to write a velocity in x direction, after some time what will be the velocity in x direction? How you will be writing? You will be simply writing ux plus ax into t. Ux plus ax into t, and ux will be 0 because initially there is no velocity in x direction, but finally after some time there will be some velocity in x direction, and that can be written as q into e divided by m into t. This will be the velocity in the x direction. Is it clear? Correct. Now, but what kind of path will be there? We have calculated that the velocity that is equals to q into e divided by m. This is what the velocity I have told you. Q into e divided by m into time. That means, can you say velocity in x direction is proportional to time? Velocity in x direction is proportional to time. Now, when this is happening, but along with this, there is some effect of this magnetic force as well, which is perpendicular to this direction. I can say it is moving in x direction, but there is some magnetic force which is pushing towards the inside the board. Correct? That is what kind of path it is following. It is called as helical path. What kind of path this is called as? It is called as helical path. Why this is happening, I will tell you in 3D. See, correct. This is the direction of velocity. This is the direction of velocity that initially that you have. This is the direction of electric force, and towards you it is coming what? Magnetic force. Clear? Initially velocity is given in the y direction. Electric field is given in x direction, and towards you it is coming what? Magnetic field. So due to that, what will be happening? Now imagine this electric field component will be doing what? This electric force component will be taking this charge in forward direction. Correct? Because acceleration is in forward direction and electrostatic force is responsible for making the velocity. That means now this body will be moving in forward direction. That is one case. But there is some force also that is coming towards you. That means it will be moving in x direction. That is correct. But it will be moving in some circular motion, not a circular motion. It is this kind of path is called as helical path. Helical path means what? It will be going in that direction also. Then it will be making a round, this kind of round, and it is moving forward, making round, moving forward, making round, moving forward. This kind of path is called as helical path. And why it is coming? Reason is there because there is some magnetic force in the negative z direction as well. Correct? If I have to write this complete force, how much the net force that is applied here, you can say net force, Lorentz force is equals to QE I vector plus, along with that, QVB into, in which direction? It is actually minus sign will be coming here due to the negative k direction. This is the net force that is applied on this body. Correct? I will be telling you about the radius also. Radius, how we write? This is a kind of circular path. When we will be understanding that circular trajectory, then I will be telling you about the helical path also. There are two things, there are two terms that are described here. What are those two terms that I will also describe you? Two terms that we describe here. One is the radius of this circular kind of path. Okay, and the second one is pitch. What is pitch? Pitch is distance between these two circular portions that have been made. This distance between them is called as pitch of the helical path. So it will be completely increasing pitch, because there is with time the velocity is increasing. With time, if velocity is increasing, can I say this distance is going to be increasing as soon as this is moving forward. More velocity, that means more pitch. The distance between two rounds will be even greater. Correct? So now if it is moving at some angle theta, then what will be happening? If Q moving at an angle theta with both electric field and magnetic field, this is again electric field, this will be the direction of magnetic field also. So let's suppose it is moving at some V at some angle theta. So what I will be writing about Vx, x direction velocity, how I will be writing? I will be writing it as V cos of theta, and this velocity I will write as V sin of theta. V sin of theta. Now, due to this perpendicular velocity, this will be deciding the pitch, and this will be deciding the radius. How it will be deciding, that also I will tell you. And about the x direction, I have already told you. Vx will be written as simply ux plus ax into t. Ux, initial velocity in x direction, is nothing but v cos of theta, plus acceleration is there, that is equal to qe divided by m into t. So can I say, as the time is increasing, that means I can say velocity is also increasing in the x direction. If velocity is increasing, I can say this pitch, let's suppose the distance is p, it will be keep increasing, p dash and p double dash, and this will keep increasing because the velocity in x direction is increasing. Is it clear? But the velocity in y direction is not increasing. Velocity in y direction is not increasing because there is no force responsible for increasing that velocity in y direction. That means this radius is actually going to be constant. And if I will tell you the formula also, r is equal to mv sin theta divided by qb is the radius. Okay. Anyway, I will derive it also. Don't worry for that. I will be looking at every single thing. Just understand this much of the thing. What kind of motion is called as helical motion. Okay. Here you can see how I will be writing the velocity in x direction. Now, second case of same kind of, but this time electric field and magnetic field are also perpendicular to each other. Okay. Q moving in perpendicular direction to both electric field and magnetic field. Q is perpendicular to both electric field and magnetic field. So how you will firstly decide the directions. What will be the directions? V cross B. What is the direction for magnetic force? Upside. This is the upside direction. And what is the direction for electrostatic force? Here it is shown that from higher potential to lower potential electric field is coming. That means downward direction is the direction for electrostatic force. Now there are three possible cases. What are the three possible cases? If here it is given as these forces are mentioned, the magnitude wise it is QE and magnitude wise it is equal to QVB. If this electrostatic force is greater than the magnetic force, if this electrostatic force is greater than the magnetic force, that means the net force will be coming in downward direction. Agree or not? Agree or not with me? That if the net force, electrostatic force is greater, that means net force will be coming in downward direction. That means what kind of trajectory it is going to follow. Remember the projectile case? When you throw a particle from a height, what kind of motion it follows? It follows this kind of parabolic path. That means it is going to follow this kind of parabolic path. Correct? When this will be greater, because this will be responsible for taking this charge in the downward direction. But what if magnetic force is greater? What will be happening if magnetic force is greater? That is the second case. If magnetic force is greater, what I will be saying, that this trajectory will be in upward direction. This net force that will be in upward direction, that will be responsible for taking this charge slowly in the upward direction, and velocity will remain depending on the this will be responsible, this will be constant actually. If I will tell you, if it will be constant, because there is no component of force that will be responsible for changing this velocity. And there is a special type of question they always used to ask you to create a condition so that this charged particle will go undeviated. What is the condition you will generate so that it goes undeviated? For making it go undeviated, what I have to do? I can say if my magnetic force will be equals to my electrostatic force, then can I say net force is equals to 0. If net force is equal to 0, no one is taking responsible for taking in upward direction, either in downward direction. That means it will go pass on undeviated in a simple straight path. Can I say this? It is very quite logical also. It is not like I have defined some rocket science. Any doubts? If you have doubts, you can tell me in the comment section. Okay. Okay. I hope that you are enjoying this section. It is very interesting, and if I will tell you, okay, different paths are there. Even with reasoning, if you'll understand, it is very interesting. Here, the first case, when QE is equals to QVB, that means electrostatic force is greater than the QVB. That means it will have a trajectory in downward direction. Net force you will be writing here. If magnetic force is greater than electrostatic force, the trajectory will be in upward direction. And the third case, if you want to create a condition that it will be moving undeviated, if you want to move it undeviated, you have to make magnetic force is equals to electrostatic force. Once you have made both of them equal, that means there is no net force acting on it, and if there is no net force, means who is making it undeviated? And yeah, clear? Now let's try to understand what will be the force acting on a current carrying loop also. Is there any force that is acting on a current carrying loop? Yes, there is always some force that is acting on a current carrying loop also. If there is some force on a charge, and what is the force on a charge? QVB. And in a loop, what is there? Flow of electrons. There will be a lot of electrons are flowing. That means, of course, there is some force that is applied on a loop also. So how many charge is actually going to be applied? Okay, that is what we have to understand. So there was an experiment. Firstly, we have taken a loop. Okay, this kind of very soft loop we have taken, and then we have started passing some current through it. And when we have passed some current and we have applied some magnet, actually it have experienced some force. So let's say due to a current carrying loop, how much force will be acting. Okay, fine. I will tell you here only. Then there is a complete derivation that is given for you. You will be reading it step by step and doing as like in board exam how you have to write. You have to follow all these steps and all these formulas. I hope that you remember that from current electricity, I is equal to eta A E V D. Okay. So how I am going to derive this formula? Now let's understand. Very easy. There is nothing about time. See, what is the force on a single electron that you write? What is the force on a single electron? You write that EVB. Correct now? EVB. Correct? On a single electron. But what if I have to write on this complete length? Let's suppose the length is L. What if I have to write on this complete length? How I will be doing? Firstly, what I will do, I will cut an element of thickness dx and I will be focusing on this element dx at some distance x. Okay, I will be focusing only on this dx element. And I will try to write the net force that will be acting on this small force that will be acting on this dx element. How will be writing, students? E is the charge, but how many number of charges will be crossing? That is a question. You remember a term eta. Eta I have defined. What is that eta? It was equals to number of electrons divided by volume. Number of electrons divided by volume. So if I have to write the how many number of electrons are actually passing from the cross section, how I will be writing number of electrons? Simply I can write eta into volume. Eta into volume. Now how will be writing this volume? I will be writing, let's suppose some cross sectional area is A and the length is dx. So I will be writing it as A into simply dx, and then there is some velocity, drift velocity into B. Correct? Now you tell me, have you ever seen this formula? Eta E A V D into dx into B. This is what the df force. What is this complete term? Eta A E V D. If anyone remember, yes, it is what? Current formula. Here you can see the current is what? Eta A E V D. Correct? And then there is an integration, df integration. You have to integrate this dx, and B is also constant. Integration dx will be for this complete length. That means what you will be writing, integration of df is going to give you f, and here it will become I L cross B, because integration of dx will become L. So actually the formula is B into I into L, but in vector form, how you have to remember, it is I L cross B. Again I will be saying, don't get confused from L. Always make, anyways, again current is not a vector quantity, but how you have to find a direction, always for finding direction, this is the trick, this not will be given in the books. Always try to do I cross B. I cross B will always help you in solving the questions. I cross B will always give you the answer, trust me. Okay, because taking L is always students will get confused. That's why I suggest simply do I cross B. There is nothing wrong in it. Okay, because ultimately we want the directions correctly, nothing more. So here it is the derivation part you can do, and finally the answer that you will be getting here. They have did at some general angle theta, and of course if your result is coming I L cross B, that means ultimately you will be having a sin theta term also. So either you can do at some angle theta, I have told you for the in general. Now please remember this, don't get confused here. I have told you already, because agar if you have written like this, that means it is what earth ka anarth. What is mean by it is also same IBL, but the way that you have written it is going to give you a wrong answer. This is going to give you a wrong answer. What is the correct way to write? It is I into L cross B. I into L cross B. That is the correct way. Okay. And for the direction purpose, I have told you I cross B you have to do. Okay. Special case, what will be happening if theta is equal to 0? That means the angle between this is the same direction for magnetic field and it is the same direction for current as well. That means theta is equal to 0. That means force is equal to 0. Sin theta is sin 0 is what? 0. Second case, if they are in opposite direction, magnetic field, current, if they are in, both are in opposite direction, that means angle between them is 180 degree. If angle between them is 180 degree, that means you will have again a 0 answer, because sine of 180 is what? Sine 180 is equals to 0. All n pi angles are 0 in general also. And maximum force will be attained at what? When this current and magnetic field are at perpendicular 90 degree. That means what I can say, maximum force will be equals to IL cross B. That means sine of 90. Sine of 90 is equals to 1. That is the maximum thing. This is an interesting one, and the kind of question that can come. If let's suppose this kind of some loop is given, okay, this kind of random loop is given, how you will be calculating? Always try to calculate the effective length between point A and C. What is the effective shortest length between A and C? Just focus on that. There is no need of deviation for you to write. Just simply write net force will be acting is equal to I. What is the length between A and C? A and C into P. That's it. That is what the answer will be there. Okay. Don't get worried that, oh, how I can calculate the length of this random loop. Don't worry. Just write always the focus on the effective length between point A and the C. Position vector, you can say position vector. If you are drawing any position point vector, what is position vector? Vector is actually the shortest distance. So position vector you can understand from there. Correct? Should we move forward? Second thing, force applied in a loop is always 0. Force applied in a net magnetic force applied in a loop is always equals to 0. Why I am saying? Because effective length, if you were trying to calculate the position vector, you know the position vector, if you are initially and the finally also at the same position. Let's suppose you have started from here. You have started from here and again you are reaching at the same point. That means what is the effective length that you have traveled? Or the position vector, what you will be writing? 0. That means magnetic force will also be equal to 0. Sorry. Here you can see also it will give you a very good idea about the direction of force. Anyways, answer is going to be 0 because both of them are closed loop. But let's see about the directional part point of view also, how it can be 0. See what I have told you, I cross B you have to do, and you will be having the directions. Here what is the, if I will be asking you, tell me the direction of current at this point, how I will be drawing the current at this junction. This is the direction for current, okay, at this point only, at this point, and inside is the direction for magnetic field. Do I cross B, I in downward direction, showing my palm to B, I cross B. What is the direction that I am getting, students? This is the direction. At this point, what will be the direction? I cross B, I cross B. What is the direction that I am getting? F. I cross B. Can I say again? I got this one. I cross B. Here, what is the direction? This is I. Show your palm to F. I cross B. Sorry. I cross B. I and show your palm to B. I cross B. What is the direction that you are getting? This direction. That means, can you say all these force vectors are actually calculating, cancelling each other? That means net force. If I will ask you, you will say, sir, net force is equals to 0. There is no force actually acting. Here also you can see the same thing. I cross B, this direction. I cross B, downward direction. Here I, this is the direction of I, and magnetic field is inside I cross B. This is this direction. That means net angle or between all of them is 120, 120, 120. And you know, if three vectors are at 120 degree angle, the net force is equals to 0 because all of them are going to cancel out each other. This is the basic vector property that I hope that all of you are knowing about it. Correct now? Tell me about this one. Good question. What will be the answer? Find a force on the given wire. You have to tell me at this wire direction of magnetic field is outside the plane. This is the length and this is the direction for current. This angle is given as 30 degree. What will be the answer? I know that even after telling you a lot of things, most of the students will say, sir, IBL sine of 30 degree. But where you will be making mistake? Beta, always remember what is the direction you are writing about between. You are writing the direction between current and the magnetic field. Here, if I am asking you, this is the direction for current, any direction, it doesn't matter. But what is the angle between the magnetic field? Can you say it is not 90 degree? Let's suppose the magnetic field is coming outside the plane. So I can say simply they are perpendicular to each other. Then a sine of 90. Which option is coming correct? Simply D option will be coming correct. Is it clear? I'm feeling so cold here. 18 degrees Celsius. And Shimla and Manali. Correct? Try to solve this question. Let's read this question, what the question is saying. A charge of 1 microcoulomb is placed at a distance 2 meter. Okay, a charge of 1 meter is placed from a long current carrying wire. It is projected with a velocity. Okay, it is projected with a velocity 500 meter per second in upward direction parallel to the wire. Find the magnetic force experienced by the charge. What is the magnetic force experienced? What is the formula of magnetic force by a charge? Magnetic force is simply is equals to Q V B sine of theta, or also you can say V cross B. Okay. And it is already in this giving you the direction, but you know that due to a straight carrying current conducting wire, it will be a magnetic field that is inside the plane. How you can do? I cross R. I cross R, that means the direction for magnetic field will be inside the board. Now, how will be direction finding the direction of which? Anyways, the question is not asking you about the direction of magnetic force, but still, if you have to do, this is the direction for velocity V cross B. What is the direction that I am getting? It is a kind of attractive force that it will be experiencing. Okay. But anyways, magnitude wise, if I will be asking 1 microcoulomb, that means you will be writing what? 10 power minus of 6. That is what you will be saying. Correct now? 10 power minus 6 into velocity. Velocity is 500 into magnetic field. Magnetic field you have to calculate. And sine of theta. Sine of theta, sine of 90 is equals to 1. Now how will you be writing magnetic field due to a wire? Mu naught I divided by 2 pi A. Mu naught and here multiply into 2 into 2. That means mu naught divided by 4 pi. This will be completely 10 power. All of you do the calculation. Maybe calculation mistake will be there. Then 2 and the factor of 2 that I have multiplied here, and here it is coming, distance is equals to 2. This 2 will be cancelled. This will be 2 into 10 power minus of 7. Here we will be writing 2 into 10 power minus of 7. That will be equals to, now this is what we have to multiply. See, 500 into 2, what you can say? This will be again 10 power 3, 10 power 3, 10 power minus of such a 10 power minus of 10. I think that this should be the answer. 1 into 10 power minus of 10. According to me, if there is no calculation mistake, option C will be the correct answer. I hope that all of you also have cross checked it. If there is any other answer coming, then tell me in the comment section. Okay. Very good. Option C we are getting now. Let's cross check it. Correct. Exactly correct. Option C is the correct answer. That our calculation was also correct. Is it clear? So this question have helped you to find the direction of magnetic field also, apply the formula of magnetic field also, and then apply the formula of force as well. So it was, I will say, it was a good question understanding wise how to apply the formulas. Okay. So I hope that you have loved this class and you have got to know a lot of new things. Now we will be discussing about energy, work done, and the rest of the things from the next lecture. Until next time, keep learning, keep going with Tapasya. Endigo and then they go Nama Tapasya.